So we're going to talk about transformations of functions today. This is a very important topic in pre-calculus algebra because a lot of students struggle with graphing functions. You can always graph a function by plotting a table and plotting all the individual points, but that might be tedious and very long to actually graph the entire function. It might take a while to get a rough idea of what it may look like. If we want a rough sketch and a very efficient sketch, we use transformation to get a good idea of what the function may look like. The only thing is required is to know what the parent function looks like. So if you recall back, we talked about y equals x squared, y equals x cubed, y equals square root of x, y equals 1 over x. These are all of our parent functions. We'll have more, of course. But I separate transformation into two main categories. In vertical transformation and horizontal transformations, we will have shifts, compression stretches, and we will have reflections. They're either going to affect it vertically or horizontally, left, right, or up and down, or reverse, up and down, or left and right. So, if I'm adding or subtracting my parent function, it's going to be a vertical shift. If I'm adding or subtracting inside my parent function, it's a horizontal shift. If I am multiplying outside my parent function, it's going to be a vertical stretch of that factor. If I'm multiplying inside my function, it's going to be a horizontal compression slash stretch of a factor of this value reciprocated. So pay detail to the phrasing. I stated that I have a vertical stretch slash compression. However, over here, I said I have a horizontal compression slash stretch. What we're going to notice is that when we do our transformation, vertical and horizontal transformations, is that they're always going to be reversed for the horizontal transformations in particular. Our vertical transformations are going to be intuitive, but our horizontal transformations are going to be reversed, and I'll explain why in a bit. We'll also have reflections across x-axis if it's multiplying a negative value outside my function. If I have a negative value multiplying inside my function, I call that a reflection across the y-axis in particular. So then let's zoom in on shifts. I have this f of x minus c plus d, where my f of x is my parent function. These are my shifts. Plus d is going to be my vertical shift, minus c is going to be my horizontal shift. I put minus here because that's very important. So let's look at a key concrete example. F of x equals x squared. I use parentheses here to tell you what my parent function is doing. My parent function is squaring values. Everything that's going to be squared is inside my parent function. Everything that is not being squared is outside my parent function. So let's take this function f of 1 of x equals x plus 3 squared minus 2. Everything being squared is inside my function. Everything that's not being squared is outside. This is my horizontal transformation. This is my vertical transformation. Now, it is not enough to say that. You have to be specific. These are addition and subtraction, so this is a horizontal shift. In this particular, plus 3 represents left 3. Minus 2 outside my function represents down 2. Alright? If it's positive right here, if I'm adding, then I'm going to go left. If I'm subtracting, I'm going right. If I'm subtracting here, I'm going down. If I'm adding, I'm going up. Everything inside my function will be reverse of what I think intuitively, and we'll explain why. But let's take a look at the graph. The parent function, f of x equals x squared, looks like this, parabola. Now, this function right here, I'm adding 3 and minusing 2, but because this is inside my function, I'm going left 3, and I have to go down 2. The reason why we reverse everything in our parent function is because that transformation has already been applied. It is already in our parent function, it's applied on our parent function. So we don't really see it. We see the aftermath of it. Whereas this minus 2 down 2 is outside my function. This is what we currently see. We call this the image in particular, the graph. We're not talking about the pre-image. So let's take another example. F of 2 of x equals 3x minus 9 squared minus 2. Now, there's a problem with this. There is a coefficient in front of this x. Earlier, I stated that these transformations, I only have a single x here as a coefficient. I have a coefficient of 1, not a value besides 1. So that means I need to factor that out. So I can have a coefficient of 1. I'm going to factor out this 3, then I have 3 times x minus 3 squared minus 2. Now I have a horizontal transformation because it's inside my function, right 3. It's negative, so I'm going right, and it's 3 instead of 9 because I factored it out. I'm going down 2 because it's the same as the exact other problem over here. All right? You always have to factor it out. I'm going to see a lot of students say this is a transformation of right 3, but that is incorrect. Right 9 is incorrect. It should be right 3. So let's talk about stretches and compressions. These are multiplying. So I have AF of B of X. This A, if it's multiplying outside my function, it's going to be a vertical stretch slash compression. It's a stretch if that A value is bigger than 1. I don't care about if it's negative. That's a reflection. So if it's bigger than 1, it's a vertical stretch. If it's less than 1 and bigger than 0, so that means it's not a negative value, then that means it's going to be a vertical compression if it's a fraction in particular. I say it's a vertical stretch of A, or I say it's a vertical compression of that value A. All right? Now, if the multiplication happens inside my function, if it's bigger than 1, well, I have to reverse it. It's not a horizontal stretch. It's a horizontal compression, and I'm going to reciprocate. I'm going to reverse that value in particular. Instead of saying it's a horizontal compression of B, this should be a B value right here, so I apologize. Fix that up. Of B. It should be a horizontal compression of 1 over B instead, or swap the numerator and denominator. If it's between 0 and 1, if it's a fraction in particular that's less than 1, then we say it's a horizontal stretch. So remember, we have to reverse it. And we say it's a horizontal stretch of 1 over B instead of B. All right, let's take a look at example. F of x equals x squared. I have negative 2 times 3x squared. This is outside my function, so we're going to say it's a vertical stretch of 2. It's bigger than 1, so we say it's a stretch of 2. Now, inside my functions are my horizontal transformation. So this is a horizontal. We have to reverse everything. This is bigger than 1, so we say it's a horizontal compression because we reverse it. Of not 3, but 1/3. I have to turn that into a fraction and then reciprocate it. All right, let's take another example. 1/2 times negative 1/3 x plus 9 squared. I'm just going to factor it because that's a habit of mine. I like to factor things immediately, so I'm going to factor it out. Now, this is outside my parent function, which is being squared. So this is a vertical compression of 1/2 because this is smaller than 1. Now, this is smaller than 1, but it's inside, so it's a horizontal stretch. I reverse it. Of not 1/3, I have to reciprocate that. So it becomes a horizontal stretch of 3. Reflections. If it's negative outside, or if it's negative inside my functions. Now, I want you to consider this real quick. Let's take this point on f of x, my parent. I reflect across the y, I reflect across the x. If you just look at this, which one do you think has a vertical transformation? Which one did I move up and down? Which point from the green point in particular? Well, it has to be the pink one. So that means it's a vertical transformation, which is outside my function. So if I have a negative outside my function, it's a reflection across the x-axis. Likewise, or similarly, if it's a negative inside my function, I move left or right. So it's a horizontal transformation or a reflection across the y-axis. This is how I remember to do these problems. So I don't really memorize it. You can, but that's a lot of memorization in my opinion. So boom. If I have if it's inside, the negative is inside my function, it's a reflection across the y-axis. If it's outside the negative, then it's a reflection across the x-axis. Now let's tie it all together. So I've written down this little schematic right here. I don't know if they have this in the book or not, but I just kind of constructed it. Everything outside will represent that outside transformation slash vertical. Everything inside will be that horizontal transformation. Horizontal will reverse things, and the vertical transformation will be what we think intuitively. So the negative represents reflection across the x-axis. If I have a value of a being multiplied, it's a vertical stretch slash compression of a value of a. If I have this plus d, I have a shift up or down that value d. The negative is a reflection across the y-axis over here if it's inside. If the b value being multiplied inside, we say is a horizontal compression slash stretch of 1 over b. I reversed it. And then the C value is a shift right or left of C. I should reverse this too, so I apologize for that. Okay? So that wraps it up for transformations. Be sure you know the shifts, stretch, compressions, and reflections. I would separate into vertical and horizontal transformations so you are more aware. You will have homework that gives you practice on this. I will catch you later. Take care. Bye.